Hello, Algebra 2 people. Sorry it took me so long to do this. It's been kind of busy lately. So here is your video for your quest that will happen on Monday, which is only going to be, I believe, 7 or 8 problems. Basically, 1 or 2 from each one of these sections. So in this first section, what you want to do is you want to work backwards. So this first piece of information tells you where to draw your triangle. So 270 to 360 tells me to draw my triangle here. And then the next piece of information tells me how to label my triangle. So cosecant theta is going to be the hypotenuse over the opposite, since it's the reciprocal of sine. Your hypotenuse is always positive, so the negative goes with the opposite. And using Pythagorean theorem, you will figure out that that adjacent side is a positive 4 because x is positive in that quadrant. Then all that's left for us to do is figure out the ratio that goes with cotangent. So that's going to be your adjacent over opposite, since it's the reciprocal of tangent. My adjacent is 4 and the opposite is a negative 3. Okay, so then we go to the next one. We start at the end. This tells me I'm going to draw my triangle in the second quadrant between 90 and 180. And so here's the right angle. Notice the triangle always goes to the x-axis. So I'm going to label my triangle. Sine is opposite over hypotenuse, so this will be 4. Opposite is a positive 1 in that quadrant. To figure out the x value, I am going to do Pythagorean theorem. So I know that 1 squared plus the x squared equals 4 squared. So then solving for x, I subtract this, so we get 16 minus 1, which is the square root of 15, because we have to square root it at the end. Here's the hard part, though. Remember, this will be a negative, because in this quadrant, x will be negative. That won't come out from the Pythagorean theorem. So now we are left figuring out what is the secant of theta, which represents the hypotenuse over the adjacent. So that will be, the hypotenuse is 4 over a negative rad 15, and we have to rationalize that. So we multiply top and bottom by rad 15, and that gives us an answer of negative 4 rad 15 over 15. That would be your final answer. Okay, and then the next one. So we have the triangle is going to be between 180 and 270. So that's going to be down here. And tangent is the opposite over the adjacent. So in this quadrant, x and y are both negative. So this is a negative 24 and a negative 7. If I make a ratio out of those, the negatives cancel. That's why you don't see it. Okay, now on this one, there's a little bit of a twist because we can't go straight to the triangle. We have to use our double angle identity. Sine 2 theta is equivalent to 2 sine theta cosine theta. And so once you use that identity, now I can go to my triangle and I'm going to substitute. Sine theta is opposite, I forgot to fill in the hypotenuse. This is also a Pythagorean triple, which is what you will have on the quest. That would be a 25 if I did 7 squared plus 24 squared. And then you would get 25. Okay, so now I can do opposite, which is negative 24 over 25. Cosine is adjacent, which is negative 7 over 25. And in front we have basically 2 over 1. And when I multiply that all together, you are going to get a positive, because you have a negative times a negative, 336 over 625, and that does not reduce, so that's your final answer. All right, and the last one of these, we're going to draw the triangle in the second quadrant, 90 to 180. So here's our triangle, and Cotangent is adjacent over opposite. So the adjacent is negative, the opposite is positive, and this is a 3, 4, 5 right triangle. Again, I have to use an identity. You have 3 options. I did one option on your hard copy of your solution, so this time I'm going to use a different identity to show you would get the same answer. So I'm going to use that identity. So I go to my triangle, and cosine is going to be negative 3/5, and I substitute it in. So I am going to have to square it. So this one I do have to simplify a little bit. So this is going to be 2 times 9 over 25 minus, and since I have to join these together, I'm going to write 1 as 25 over 25 with the same denominator. So this is 18. 18 minus 25 is a negative 7. And if you notice, it's exactly the same answer as we had on the other copy. So it doesn't matter which identity you can use. It's all up to you. All right, now we have our sum and difference properties, and you're going to expand and use your unit circle to come up with an exact value. So make sure you put your unit circle on your note card. So for sine 75, I'm going to use 30 plus 45, and there is more than one way to do these, but that's what I'm choosing. So then I expand this sine 30 times cosine 45 plus cosine 30 times sine 45. And then you guys would be looking at your unit circle. I know what these are. This will be 1/2. Cosine 45 will be root 2 over 2. Cosine 30 is root 3 over 2. And 45 for sine is also root 2 over 2. Once you fill those in, you just simplify it. So this is rad 2 over 4 plus rad 6 over 4. And your final answer, these will always kind of look like this over a common denominator of 4. So then we have cosine, 105. So for this one, I'm going to use cosine of 45 plus 60 and expand. So cosine 45, cosine 60 minus sine 45, sine 60. So you just want to use your sum and difference properties, use your unit circle, and then we substitute. So this is rad 2 over 2 times 1/2 minus rad 2 over 2 times rad 3 over 2. Notice they look very identical. So we end up with rad 2 minus rad 6 all over common denominator of 4. Okay, this last one is the one I know that caused people the most anguish. If there is one on the test, it would be an extra credit. So I'm not going to make you do one of these because it does require a lot of algebra and multiplying by conjugates. So I don't want you to get lost, the concept to get lost. So 15 degrees, I would write this as 45 minus 30. And then that would expand as tangent 45 minus tangent 30 all over 1 plus tangent 45 tangent 30. And anywhere you see tangent 45, that equals 1, which makes things a little nice. Tangent 30, you can use the ratio or you could simplify it. I'm just going to leave it as 1 over rad 3. So this becomes 1 over rad 3. So what I have here is 1 minus 1 over rad 3 over 1 plus 1 over rad 3. We can leave off the times 1. So fraction over fraction is pretty ugly. So what I'm going to do is I'm going to multiply top and bottom by rad 3. That's going to give me rad 3 minus 1 over rad 3 plus 1. And because we're not allowed to have a radical in the denominator, we have to multiply top and bottom by the conjugate rad 3 minus 1. So we want to have the opposite of that sign. So this gets rad 3 minus 1. So the denominator, you can do your a squared minus b squared. So this becomes 3 minus 1, which is 2. The top we have to FOIL out. So rad 3 times rad 3 is 3. If I did the last terms, I'm going to have a plus 1. And my middle terms will give me negative rad 3 twice, so that's negative 2 rad 3. This simplifies to 4. And I'm kind of running out of space here, so I'm going to do it right up here. So I have 4 minus 2 rad 3 all over 2. And I can factor out a 2 from the top so that they cancel. And here is your final answer. Okay, on to the next page. All right, hello again. So we are going to expand and use our unit circle to simplify each one of these expressions. So using your sum and difference property, this is going to expand to sine x cosine 90 plus cosine x sine 90. Then we have a minus, and we're going to expand this one. So it's a long term. So cosine x cosine 180 minus sine x sine 180. And what I'm going to do is put all that in a parenthesis because there is a negative sitting out in front of all of that. So what we're going to do now is look at anywhere where I would have a 0. Cosine of 90 is 0, which means this whole term is just going to go away. Sine of 90 equals 1, so we only have the cosine x. Cosine of 180, that's going to equal a negative 1, so that's going to make that term negative. Sine of 180 is 0, so that whole term goes away. So this whole thing kind of simplifies into, I have a cosine x here minus a negative cosine x because of the negative and the negative. So I have cosine x plus cosine x, which gives me 2 cosine x. And that's how that would simplify. Okay. The next one, number 9. I think you guys prefer sine and cosine. So first thing I'm going to do is rewrite this as 1 over sine, and this is cosine over sine. And that is going to get FOILed to 1 minus cosine. So our first terms, when we FOIL, is just going to give me 1 over sine x. My outer term is going to give me minus cosine x over sine x. My inner term is going to give me plus cosine x over sine x. And my last term is going to give me minus cosine squared x over sine x. So it looks like a mess, except notice these middle terms are the same with different signs, so they basically cancel each other out. So we have here 1 over sine x minus cosine squared x over sine x. We have a common denominator, so I'm going to write it all as one fraction. Hopefully then you notice by your Pythagorean identities, this equals sine squared x, and again, you want to show me every step when you're doing these. You don't want to skip something. And then we can see that this one sine will cancel with that, so our final answer is just sine x. Okay? And then apparently I skipped number 10 on the worksheet, so let me do it now. Secant squared over tangent squared. If you look at your Pythagorean identities, that actually simplifies to 1. On the bottom, cosine pi over 2 minus x, it's a co-function. That's one of your properties, so that simplifies to sine. Secant is the reciprocal of cosine. So secant can be written upstairs as cosine. And so you have cosine over sine, which is cotangent. So it actually, as ugly as it looks, if you just use your identities and your properties, it's simplified very nicely. Okay, now we're going to do identities. The thing about an identity is you can only work on one side, and you keep going until you get exactly what was on the other side. Doesn't matter what side you work on. So in this one, I am going to start on this side, and I'm not going to touch the first side. So whenever you see a 1 plus sign or a 1 minus sign, 1 plus cosine, 1 minus cosine, you can't use your Pythagorean identity, nothing squared, but I can create a Pythagorean identity by multiplying by the conjugate. So I have to multiply top and bottom, and it doesn't matter which side you work on. This will work either way. So what I have on top now, when you multiply the conjugates, it becomes a squared minus b squared. So if I FOIL that, I get 1 minus sine squared theta over, and this I'm not going to distribute, I'm going to leave it in factored form, because what happens is you always get the Pythagorean identity on top. That turns into cosine squared theta. So I still have cosine theta 1 plus sine theta on the bottom. And this squared cancels with that, so that I have cosine theta on top over 1 plus sine theta, and that matches with our other side. So we're done. Okay, so on number 12, what we're going to do initially is we are going to distribute. So let's start this one with purple. Okay, so I'm going to distribute. So I have sine theta, cotangent theta, plus sine theta, tangent theta. All right, so let's rewrite all of this now in terms of sine and cosine. So cotangent is cosine over sine, and tangent is sine theta over cosine theta. So let's see what we got here. This sine is going to cancel. So what I have so far is cosine theta plus sine squared theta over cosine theta. I have two terms, and I'm trying to get it to equal just one term. How do you make two fractions into one? You need a common denominator. So since my second term has a cosine in the denominator, I'm going to multiply top and bottom by cosine. Multiplying the top squares the cosine that's already there. And now notice I have the same denominator, and I have cosine squared plus sine squared on top. So that is 1 over cosine theta, which equals secant theta, which is what we wanted. Okay, so there's your verifying identities. Now we're off to solve. So the key to solving a problem is, first of all, you can't have double angles. If you can simplify what you have, you want to do that first. So I have to rewrite my 2 sine theta as, or my sine 2 theta as 2 sine theta cosine theta minus sine theta equals 0. Now we talked about if you have more than one trig, what you want to do is use your GCF, factor out what's common, and then set each factor equal to 0. So each factor has a sign. So I'm going to pull sine out in front. That means I still have 2 cosine theta and a placeholder of 1. And now we set each one of these equal to 0. So sine theta equals 0. And this becomes 2 cosine theta minus 1 equals 0, which means cosine theta equals 1/2. So now we go and we look at our unit circle. Sine theta equals 0. I'm going to write my solutions up here because I'm kind of running out of room. Sine theta equals 0 at 0 degrees and at 180. I'm leaving space because I'm already looking at my solutions. Cosine theta equals 1/2. When you look at your unit circle, that'll be in the first and the fourth quadrant. That happens at 60 degrees and at 300 degrees. And those would be your solution. Okay? So number 15, let's let's see, let's do this one. So we only have one trig value. When you only have one trig, you want to isolate it. So I'm going to have cosine squared equals 0. I'm going to add 1 to both sides, so that makes that a 3, and then I'm going to divide by 4. And you're like, wait, 3/4 is not on our unit circle. Aha, but wait. If we take the square root of both sides, remember we have to put in a plus or minus, that gives me cosine theta equals plus or minus rad 3 over the square root of 4, which is 2. That is going to be on your unit circle, and notice you have the plus or minus. So you're looking at all 4 quadrants. Rad 3 over 2 is going to happen at all the 30-degree reference angles. So theta is going to equal 30, 150, 210, and 330. You'll have 4 different answers, and it doesn't matter because it'll be positive here and negative here. All right, on number 16, when we see this, remember you cannot distribute the cosine to each term, but I can use my sum and difference property to expand this. That would expand as cosine 270 cosine x plus sine 270 sine x equals 1/2. So what happens now is cosine of 270 is 0. So I have sine of 270, which equals a -1 times sine x. And so we have, I'm going to move the negative to the other side. So I have the sine of x equals a -1/2. And looking at your unit circle, this will happen in the second. No, wait, this is sine. So it's going to happen in the third and the fourth quadrant where the y values are negative. And so you're going to have x equals 210 and 330. Both have 30-degree reference angles. Okay, last problem. So we want to utilize our GCF since we see more than one term. So that means I'm going to first bring everything over to one side. Sorry, I wrote that wrong. I do that all the time with cosecant. I always leave off that little c. Okay, great. There we go. Minus 2 CSCX equals 0. Okay, now I can do my GCF because I have a cosecant common to both terms. So I have cosecant x equals 0. Oh, sorry. I'm getting excited because I'm almost done. So let's do it step by step. Let's pull the cosecant x out. And then we have secant x minus 2. This all equals 0. So we set cosecant x equal to 0. And we set secant x equal to 2. So minus 2 equals 0. Add the 2 to the other side. Now, if you don't like doing the secant, let's rewrite this as cosine, but we're taking the reciprocal of both sides, so that equals 1/2. Cosine is going to equal 1/2 at 60 degrees and at 300 degrees. So cosine is positive in those in the first and the fourth quadrant. Cosecant is going to equal 0. If you think about the graph, remember that's the one that has the little parabolas going up and down, and wherever sine was 0, you had an asymptote. So this one actually has no solution to it. So our final solution is just what we get from the cosine or the secant version. Okay, I hope that helps, and I'll see you guys tomorrow.